Section 5: Tropical Storms and Hurricanes. Digging deeper. Hurricanes. In the Investigate, you used hurricane data to determine which areas in the United States are most likely to experience hurricanes. You then used data to track the path of a hurricane. This digging deeper will help you to understand how hurricanes form and travel. It will also help you to learn about the effects of hurricanes once they make landfall. Storm systems that build up to hurricane levels go through several stages. These systems start as tropical cyclones. A tropical cyclone is a storm system with a large center of low pressure, very strong winds, and intense rain. These types of cyclones form over warm tropical or subtropical waters. They start out as low-pressure cells that break away from the low-pressure belt near the equator. Every few days, areas of unsettled and stormy weather develop. These disturbances in the atmosphere provide the seeds for tropical cyclones. Tropical cyclones become tropical depressions when their surface winds are sustained at a speed of 61 kilometers per hour or 38 miles per hour or less. The next stage is a tropical storm. A tropical storm has winds of 117 kilometers per hour or 73 miles per hour or less. At this stage, the storm is given a name. The name is assigned by the National Hurricane Center in Florida from lists maintained by the World Meteorological Organization. The storm system is categorized as a hurricane when the minimum 1-minute sustained surface wind is 119 kilometers per hour or 74 miles per hour or greater. In the western North Pacific Ocean, hurricanes are called typhoons. In the Indian Ocean, they are known as cyclones. For a hurricane to build, upper-level winds must not be too strong or change too much. Otherwise, the storm will be pulled apart. Hurricane building. The storage and transfer of thermal energy from the oceans to the atmosphere plays a big role in the formation of hurricanes. During late summer and early fall, the surface of the oceans is at its maximum temperature. Remember that the heat capacity of water is high. More heat needs to be added to or removed from water than land to result in a temperature change. Therefore, the oceans heat up slowly compared to land. Ideal conditions occur when the ocean is around 27 degrees Celsius or 80 degrees Fahrenheit to a depth of 45 meters. As ocean water evaporates, energy is absorbed, but the temperature does not change. Energy is required to enable the water molecules to move more quickly and change state from liquid to water vapor. In a sense, the absorbed energy is hidden. The warm, moisture-laden air rises into the atmosphere. The surrounding atmosphere is relatively cooler. Condensation occurs and the water vapor becomes liquid again. The energy is then released inside the tropical cyclone. If upper winds remain light, the storm can become stronger. This occurs as air continues to flow toward the low-pressure center where uplift dominates. At this stage, the storm appears as a somewhat unorganized cluster of thunderstorms. If the system can strengthen to become a tropical depression, the storm appears as a cyclone. The Coriolis effect controls the direction in which a cyclone spins. In the northern hemisphere, air veers to the right to produce a counterclockwise rotation. In the southern hemisphere, the opposite occurs. Despite warm waters, the area that lies 5 degrees to either side of the equator does not generate hurricanes. That is because the Coriolis effect is weakest there. Without the rotation of air masses, cyclones cannot form in this region. Hurricane classification. Hurricanes can achieve diameters in excess of 800 kilometers or 500 miles. However, most are less than 200 kilometers or 125 miles. Air moves across the oceans toward the center of the storm. This is where the atmospheric pressure is lowest. The area is called the eye of the hurricane. In Part C of the Investigate, the hurricane data you analyzed and tracked was from Hurricane Katrina. This was one of the most destructive hurricanes to ever strike the United States. It made landfall in August of 2005. As the data you examined shows, the atmospheric pressure for this hurricane fell to 902 millibars in its center. The eye of a hurricane is a relatively calm area with clear weather. It is about 30 to 60 kilometers, 20 to 30 miles across. This is where the air sinks. The air is warm and rich in moisture. At the eye wall, powerful vertical winds raise the air upward. Here, it eventually spirals outward as bands of rain. During a hurricane, the eye wall can expand and contract as the storm changes size. As the hurricane matures, rain bands can contain thunderstorms that range from a few kilometers to tens of kilometers wide. During a hurricane, the eye wall can expand and contract as the storm changes size. As the hurricane matures, rain bands can contain thunderstorms that range from a few kilometers to tens of kilometers wide and 50 to 300 kilometers long. Hurricanes can drop tens of centimeters of rain in an hour. The upward motion of air causes very low atmospheric pressure. This creates severe wind speeds as air moves inward from surrounding areas of higher atmospheric pressure. Hurricanes are classified into categories by their wind speed using the Saffir-Simpson Hurricane Intensity Scale. The central pressure, 1-minute sustained wind speeds, and storm surge for each category are shown in Table 4. The movement of a hurricane. The movement of a hurricane depends on the atmospheric conditions around it. The forward speed of a hurricane averages between 25 to 32 kilometers per hour. However, it can be more than 95 kilometers per hour, 60 miles per hour. Some hurricanes slow down and can cause torrential rains and flooding. Most hurricanes stay in the tropics. Only sometimes do they pass through to mid-latitudes. They are affected by the strength and direction of the trade winds. Recall that the trade winds are persistent patterns of easterly tropical winds that blow toward the equator. Hurricanes are generally pushed from east to west across the oceans. Ridges of high pressure in the atmosphere can block the path of a hurricane. These ridges can steer the movement of the hurricane. Generally, the right side of a hurricane relative to the direction it is traveling is the most dangerous part of the storm. This is because of the overall effects of the hurricane winds and the general flow of the atmosphere. Hurricanes that make landfall typically last for about 5 days. Hurricanes that remain over the ocean can last up to 2 weeks. They die out as energy is transferred to generating winds and rain. Hurricanes may die if upper winds tear them apart. They also die out from moving over cooler water. When hurricanes move over land, their source of energy is cut off. The storm will eventually dissipate as energy is required to overcome friction. Sometimes a hurricane may leave land and return to sea. There, it can strengthen by gaining energy from warm ocean water. Hurricane storm surges. High winds and flooding are the two greatest destructive forces of hurricanes. The most severe and life-threatening phenomenon associated with hurricanes is a storm surge. This occurs as a bulge of water that develops in the low-pressure center. It moves along with the hurricane. As the storm surge approaches the shore, the ocean becomes shallower. The winds drive the elevated surface of the bulge toward the land. The height of the hurricane waves in severe conditions can reach 12 meters or 40 feet. About 90% of the deaths caused directly by hurricanes result from the high water and large waves of the storm surge. The timing of the event and the makeup of the coast are also important factors. Low-lying and flat coastlines are often badly affected. This is especially true if the hurricane makes landfall at high tide. North America's deadliest natural disaster from a hurricane took place in 1900. On September 8th, Galveston, Texas was hit by winds of 135 kilometers per hour or 84 miles per hour. The topography of this city is low-lying. It averages less than 1.5 meters or 4.5 feet above sea level. The 6 meter high or 20-foot high storm surge took many of the 6,000 lives that were lost. Hurricane Katrina. Hurricane Katrina became the most destructive hurricane to ever strike the United States. On August 25, 2005, it struck southern Florida. At that time, it was a Category 1 hurricane. It caused severe flooding. Many people lost power. Katrina then strengthened quickly as it moved westward into the Gulf of Mexico. In 2005, these waters were 1 to 2 centigrades or 2 to 3 degrees Fahrenheit above normal. Katrina turned northward during the next few days. It continued to strengthen. Changes in the eye wall disrupted the strengthening. However, it caused the storm to nearly double in size. On the morning of August 28th, Katrina again grew more intense. It attained a Category 5 status. Winds were recorded at a maximum of 280 kilometers per hour or 175 miles an hour. With a minimum central pressure measurement of 902 millibars, Katrina became the fourth most intense Atlantic hurricane on record at the time. Before Katrina reached land, rainfall from the outer bands was measured at about 2.5 centimeters per hour, or 1 inch of rain per hour. Katrina struck land for a second time on the morning of Monday, August 29th. It struck as a Category 3 hurricane. Landfall was near Buras Triumph, Louisiana. Katrina had sustained winds of 205 kilometers per hour or 125 miles an hour. In just over 3 hours, 7.5 centimeters or 3 inches of rain had fallen. By the end of the event, as much as 8 to 10 inches of rain had fallen along the path of the hurricane. The impact of Katrina was due in large part to its huge size. This was the case even though it was only a strong Category 3. Hurricane-force winds extended outward for a radius of 190 kilometers or 120 miles from the center of the storm. The storm retreated to southeastern Louisiana and Breton Sound. It then struck the border of Louisiana and Mississippi as a Category 3 storm. Katrina maintained its intensity as it moved north. It finally lost hurricane strength more than 240 kilometers or 150 miles inland. By the time it reached Clarksville, Tennessee, its energy had dissipated to a tropical depression. Rainfall amounts were between 5 to 10 centimeters or 2 to 4 inches. The rain spanned the region from the Gulf Coast to the Ohio Valley. On August 31st, the effects from Katrina were noted in the eastern part of the Great Lakes. Destruction from Katrina. Severe destruction was widespread along the Gulf Coast from central Florida to Texas. Numerous towns were flooded. This was largely due to a 6 to 9 meter, 20 to 30 foot plus storm surge. The surge reached far inland. Many parts of New Orleans, Louisiana, are below sea level. A system of levees was in place to support the waters of surrounding lakes and canals, including Lake Pontchartrain. They protect New Orleans from flooding. Strong winds, rain, and the storm surge caused the levee system to fail catastrophically. Parts of New Orleans were flooded beneath 6 meters or 20 feet of water. Flooding was widespread in the city. The floodwaters reached depths of up to 9 meters or 30 feet and did not subside for weeks. The effects of Katrina were felt by many parts of the economy. The Mineral Management Service made an estimate of the resulting decrease in oil production. They estimated that the production in the Gulf of Mexico went down by 1.4 million barrels per day. That is 95% of the daily Gulf of Mexico oil production. Gasoline reached a record high price per gallon on Monday, August 30th. Over 1.7 million people lost power as a result of the storm in the Gulf states. Many did not get power back for weeks. Drinking water was also unavailable in New Orleans due to a broken water main that serves the city. Both of New Orleans airports were flooded and closed on August 30th. Bridges of Interstate 10 leading east out of the city were destroyed. Coastal highways along the Gulf were impassable in some places. Most minor roads near the shore were still underwater or covered in debris as of August 30th. More than 1,836 people lost their lives in the actual hurricane and in the subsequent floods. For the next 4 years, thousands of people who had lost their homes were still living in trailers. This made it the deadliest natural disaster since the 1928 Okeechobee hurricane.